How is air controlled within the environment? Air is controlled by the MVHR system, but the system itself isn't any good. There's ducts and stuff around it to suck the air out of some areas of the house and put air back into the other areas. We need a circulation and movement of air within our box. Now, we do this by a series of pipes and ductings, inlets and outlets and filters. Now, basically, the air can be controlled via ducting positioned in strategic areas. The reason I say strategic is, in other words, it's designed, it's planned. We have a box, we have a shape, we have different rooms, we have different layouts. All this will have to be calculated, so it needs to be designed purposely for an individual project. The volume of rooms will be calculated and required. Each room will require X amount of airflow in a particular direction, so therefore that will be calculated. Areas such as kitchens and bathrooms, they'll be extracted by the MVHR because that will be taken through the heat exchanger and maximises the amount of energy, the heat that we can suck out of the air. And kitchens and bathrooms are a particularly good way of doing that. Living areas such as your dining room, your lounge, your bedrooms, they're all going to be vented with fresh, clean air coming in. So it's really controlled. The better the air tightness, the easier it is for the MVHR, mechanical ventilation heat recovery system, to work. Because if you can imagine you've got a box, a sealed box, you're controlling that environment. If you get a draft coming through that, it's a non-controlled environment. Every time you get a movement of air that you don't want, it means that you're losing some of that control, some of that efficiency to which you've got. Things to remember about MVHR. This is something which I like to mention, and that is condensation. Within any MVHR system or with any heating system, you're going to get some form of condensation or moisture because you've got two temperatures working opposite to each other to come together to form one particular temperature. Therefore, there will nearly always be condensation or moisture. So an MVHR system will have a trap or a port to allow this water to come out. So when fitting the system, you must always take into consideration that you may have to get rid of condensed water somewhere. What else does an MVHR do? Well, what an MVHR does is it's doing all this work. It's taking in air, filtering it, putting it through the heat exchanger, is taking air out or filtering it, putting it through the heat exchanger, and it's doing this amazing job every second of every day. This is doing this job, maintaining a consistent and healthy environment to live in. But how do we know it's being as efficient as it can be? And that is because within an MVHR system, it has sensors. And it senses things like air volume, air temperature, moisture, and it keeps a record of that, and it stores it in the memory. So that means at the end of a given amount of time, whether it's 12 months, I always say 14 months for a test because it gives you a better variances. Once you can plug your computer in, there's a program which will work out the efficiency of your machine, how much it's cost to run and how efficient that machine has been. So it's a form of testing. We need to know it does what it does.